Alright, this is Computer Science 305, Programming Languages, and we're going to be talking about polymorphism. And specifically, we're focusing on subtype polymorphism and definition and classification of polymorphism in this section of the lecture. And so, subtype polymorphism is what we typically think about in object-oriented world. So you have a functional operator exhibits subtype polymorphism if one or more of its parameters has subtypes. So, think about this like in Java you have a method that takes in, for example, a class that has subclasses. So that more abstract class or interface has the capability, makes that method have subtype polymorphism, right? It can handle the base type as well as all of its children through object-oriented polymorphism. So, important source of polymorphism in many languages with rich structure of subtypes. Think Java, C++, even ML. So, explicitly object-oriented languages, or especially object-oriented languages, as I just said, Ruby also has a lot of this, but Ruby has a special way of doing it through dynamic typing anyway. But another example would be Pascal, right? So we create a type, and in this type, it essentially has the days of the week, right? And then it has a special subtype called a weekday, which is only Monday through Friday. And so we have a function attached to this for next day, which goes and says, given a day, what is the day after that, right? So if day is Sunday, the next day equals Monday. Otherwise, the day equals d plus 1, right? Because it's a list, but unfortunately, it's not circular. So we also have a procedure, which then says, given a day and a weekday, right, what we're going to say is D is the next day, and then D is the next day W, right? So what this is basically saying is it's going to handle either a day or a weekday, but next day is the actual polymorphic method, right? It handles our polymorphic function in that it can handle any type of day, regardless if it's a day or a weekday. In Java, right, we should all know about this, is that we have we can create class hierarchies, right? So if we have a class car with a single method break, we can create a manual car, or what used to be called a standard, which has a clutch, and then we could also theoretically create another car that has another form of transmission beyond an automatic. And so we create a function or a method G that takes in a car Z, right, and it calls the known method break, right, which is inherent in all which is inherited by all the classes subtypes of car and is available in car itself, right? We can then create another function F that takes in car and manual car, which is calls G of X and G of Y, right? Which is just saying that it can G can apply to either of the two types, right? So in essence, G, because of its polymorphism, can handle unlimited types as long as the number is subject to the bounds of how many subtypes there are of car itself. So as we'll learn more about this as we start talking about object orientation later in the class, and we'll get more into subtype polymorphism. Finally, definitions and classifications, right? So we've seen 4 different types of polymorphic functions, right? And then we had polymorphic variables, classes. There's all other uses of this, including polymorphic classes, packages, languages. Interesting, another name for this is runtime method dispatch. When we call x.f, right, may call many different methods depending on the runtime class of object X. So, and the word polymorphism itself is actually used in a bunch of other sciences. So, it's not something that's specific to computer science, as is most of our keywords that we use. We stole them from everywhere else. So no definition covers all these uses except for the basic Greek, which is polymorphism means many forms. But here's the definition that covers everything that we've done, right? So a function or operator is polymorphic if it has at least two possible types. That is, it exhibits ad hoc polymorphism if it has at least two but only finitely many possible types. And it exhibits universal polymorphism if it has infinite many possible types. So that kind of covers our good definitions, right? Overloading, right? Ad hoc polymorphism. Each different type requires a specific definition. Only finitely many in a finite program, which is true. Parametric parameter coercion, right, is ad hoc polymorphism as long as there are only finitely many different types that can be coerced to a given parameter type. Parametric polymorphism is universal polymorphism as long as the universe over which type variables are instantiated is infinite. So, which I would say is not true unless we are considering all the future possible types that can be created, for example, in object-oriented systems. And finally, we have subtype polymorphism. It's universal as long as there's no limit to the number of different types that can be declared for a given type. Which is true for all class-based object-oriented languages like Java. There's an infinite number of possible types we can never create. We can never know how many there could be because there's always one more that could be created. So, although I would say it would be countably infinite. Alright, so that's the end of polymorphism. So there will be all sorts of really great class exercises and out-of-class exercises for you to do, as well as be aware that this will be on both homework and exams. So have a great day.